Number 7. Okay, so now we have a degree 3 polynomial, which means imaginaries, we have no i's in our polynomial. So degree 3, there has to be an even number because they would end up canceling each other out. So we could have 2 imaginaries. We couldn't have 3, we couldn't have 1, we could have 2 or 0. So degree 3, if we have 2 imaginary, there would be 1 real. If we have 0 imaginary, then all 3 are real. So let's look at the possible rational zeros. We take the factors of the last term, the constant term, which is just 1 and 2. And then we take the factors of the leading term, the one with the variable with the highest degree, and that's just 1 and 5. And then we make fractions. 1 over 1, 1 over 5, 2 over 1, 2 over 5. So now let's list the possible rational zeros, which are all of those fractions. Okay, so now we have to figure out if any of these are correct zeros. So we could either try to factor, so we could throw this into a box. So 5x cubed, x squared, negative 10x, or negative 2. We could try to factor, or we could plug in our possibilities and see which ones give me 0. Okay, so I plugged in all my possible rational zeros. Can you see which one is going to give me the 0? It's right here. Okay, so x is equal to negative 1/5 is one of my zeros. Now, what does that mean is my factor expression? So I'm going to multiply both sides by 5. And I'm going to add 1. That means 5x plus 1 is one of my expressions. Okay, so degree 3, I have found one of my zeros. I need to find the other 2. So if I know that this is one of them, how can I find out what the polynomial looks like after this is taken away? So we can do long division. Now, the question is, can we do synthetic? Synthetic division, I feel like, is more complicated when you have a coefficient in front of the x, or when this is a fraction. You could, if you're really, really committed to doing synthetic and never doing long division, but let's do long division. Okay, so do we remember the steps of long division? Step 1, we're going to make it match. Just that first term. Okay, take 5x cubed, divide it by 5x. What needs to go here so that I could multiply by 5x to get 5x cubed? Okay, we could see that that is x squared. Either what times 5x is 5x cubed, or you can use division. So next step, multiply. 5x times x squared is 5x cubed. 1 times x squared is x squared. Okay, next term, subtract. Disappear, disappear. negative 10x comes down. Okay, so since we have two terms and my x squareds disappeared, I'm going to go ahead and bring down the negative 2 as well. Next step, make it match. 5x times negative 2 is negative 10x. 5x 1 times negative 2 is negative 2. Cancel. Add down, remainder 0. So this is what I have so far. The zeros are 5x plus 1 and x squared minus 2. Okay, so this one gives me my negative 1/5. I need to get the zeros out of this one. So x squared minus 2 is equal to 0. Add 2 to both sides. X squared is equal to 2. Take the square root. X is equal to plus or minus rad 2. So here's my zeros. Rad 2, negative rad 2, negative 1/5. Okay. Number 8. Okay, so degree 3, that means there could be two imaginaries. Okay, they always have to be an even number because we don't have any i's in our polynomial. So to add up to 3, that would be 1. There could be 0 and 3. So possible rational zeros. We need the p's, which are the factors of 1, and the q's, which are the factors of 4. So we need to make fractions. So plus or minus 1, plus or minus 1 over 2, plus or minus 1 over 4 are our possible rational zeros. Okay, and I'm going to put a 0 over here. Now, let's try a different strategy. For this one, what if we tried to factor? So what if we put our 4 terms in a box and let's see if we can factor it. So top row, I can see they have a GCF of 4x squared. 4x squared times x is 4x cubed. 4x squared times negative 1 is negative 4x squared. X times negative 1, negative 1 times negative 1 is 1. So I could see that this factors into 4x squared minus 1 and x minus 1. So if you can factor it, especially if it's a degree 3 and you can factor it and bring it down to a degree 2, now I could see that this one is factorable again. So we have x minus 1 over here. 4x squared minus 1 is the difference of two squares. So we have 2x plus 1, 2x minus 1. So our zeros, let's set each one equal to 0. Subtract 1, divide by 2. Add 1, divide by 2. And add 1 to both sides. Number 9. So we can see that we have 12 apple pies, 4 blackberry pies, gave us $96. Okay, so if the apple pies are X's, the blackberry pies are Y's, we have 12X plus 4Y equals 96. And then we have 2 apple and 8 blackberry gave them $82. 2 apple plus 8 blackberry is 82. Okay, so now we have a system of equations. I'm going to choose a variable to cancel. So let's cancel. I'm going to choose X. So how can I add down and make the X cancel? I want this to be negative 12. So in order to get my X to be negative 12, I'm going to multiply by negative 6. So we're going to bring the top down. And then the second equation becomes negative 12X minus 48Y is equal to negative 492. So now I'm set. I can add down and my X's will cancel. So the X's cancel. I have 4Y plus negative 48Y is negative 44Y. 492, negative 492 plus 96 is negative 396. Divide by negative 44. Y is equal to 9. So let's go back. Let's go back to the second equation. 2x plus 8y is equal to 82. If y is 9, 2x, 8 times 9 is 72. Subtract 72. 2x is equal to 10. X is equal to 5. So X's are the apple pies. The apple pies cost $5. The blackberry pies cost $9. Number 10, 2 taxi companies charge this amount. Okay, so company A charges a $3 flat fee. Company B charges a $5 flat fee. So we're going to write equations to see at what point would you be paying the same amount no matter which company you choose, A and B. Okay, at how many minutes or how many miles are they equal to each other? So here's the important thing. Flat fee of $3, $2 per mile, which if I were to graph that, where is the y-intercept? Where does it begin and how much is it moving? Can you see that it begins with $3 and moves $2 per mile? Keyword being per, that's telling us. So that's telling us B is 3. The y-intercept is 3. The slope is 2. So we have 2x plus 3. Some people, it makes more sense to say 3 plus 2x, and that's fine too. So flat fee, that's where it begins. $1 per mile is where it moves. So we have 1x plus 5. Okay. Y is the total cost. X is the number of miles traveled. So A, write a system of equations to represent. System of equations means 2 equations, two unknowns. There is my system of equations. Now B, determine how many miles you would need to travel. And at this point in time, the cost would be the same no matter what company you choose. Okay. Now, number 9, we had two equations in standard form. Number 10, notice I have y equals y equals. Number 9, I used the elimination method. Number 10, when I have two equations in y equals, I'm using the substitution form. So we're going to substitute x plus 5 in place of y. So I have x plus 5 is equal to 2x plus 3. Subtract x from both sides. Subtract 3. X is equal to 2. What is 2? 2 is the miles. At 2 miles, they have the same cost. Okay, so at 2 miles, what is the cost? The cost is the y. So y equals 2 times 2 plus 3, which is 7. Or you could plug it into the bottom and you would get 7. So at 2 miles, it is the same cost, which is $7. So x equals 2, y equals 7.